The stream should be live in a minute or two. Let's see how much time it takes. On YouTube it's live. On Twitter I'm not sure what's happening. Yeah, I guess it's live on Twitter too. Let me. Oh, okay. I can live on Twitter at highest resolution. Oh, cool. That's actually cool. For now, I'll just close Twitter. Okay. You guys can also go and check on Twitter what, like, how it looks. On YouTube, it's same old. Okay, ignore this part. I was trying to run code from some article and just see how, uh, just see like if it works or not. That was the only thing. Let me. Okay. Open folder. Solidity. Then we are working on P256, right? Yesterday. Today I want to work on something else. It's we can work on one of the projects. So let me open the browser. Yeah. To my GitHub profile, github.com. Okay, so these ideas are left. We have done this yesterday. It was just simple one library function and two cheat codes. It was not that much interesting. This, we already have that. I don't have to recreate it. I want to go here, but for that, uh, we need to use hard hat, and I don't want to deal with JavaScript today for writing tests. So I'm not gonna do that. Okay, so what's left? What's left is we can, what we can do is use P256 signature in the account contract. This account contract. No, we'll just create a new one, and yeah, we already know most of the things. Let's start with creating folder cd dot p256 account contract. Also, maybe from next week or next week, like I'll start going through what is that DeFi protocols like lending, borrowing, that kind of stuff. But I have to do my homework. So I'll yeah. Hopefully you guys are interested in DeFi protocols. Right now we are just focusing on account abstraction, but DeFi protocols will also be like quite nice. Okay, let's start with Forge init. Let me modify the foundry foundry.toml. I want to add required like configs, not required, the configs are like those ones. Okay, Forge soldier init dash clean dash. Do we need to add config location? No, we don't. It just asks for that. Okay, next part is just working on installing the dependencies, which is account abstraction and the library from vectorized, which was Solidity, I think, this one. Copy Forge soldier install Solidity 0.1.10, then the zip URL. Okay, this works. Remaining is account abstraction. Account ETH infinitism account abstraction. Yeah, they should be good. Release, copy the zip URL, the link, account abstraction 0.7.0. Okay, now I want to modify things. So first, account abstraction dependency, we directly want to go to contracts, and both for the remaining dependencies we are just gonna say source. Okay, 5 views. Damn. On Twitter, if you go and see on Twitter, like, you'll see it's quite good. it says 5 views. Who knows who is watching? Okay, these things are done. Let's get back to working on our contract. It will be same. We already know the flow, how things work. Okay, that now source P256 account.sol pragma directive 0.8.28 imports base account abstraction /core/base account. Oh, import P256. What's next? So already utilize utils P256. Now contract P256 account is base account. We need to implement two functions, which is entry point and this validate this one and this one. Okay, we have few more imports. Entry point account abstraction / interfaces entry point.sol packed user operation account abstraction / interfaces / packed user operation. Okay, yeah, just overriding those things. Done. We need to create variables. Entry point public key, then signature, no, so these are structs that we need, and this one is state variable. What else do we need? Oh, sorry, we also need s_pub key. We have this, Do we need also ownable? Does base account? No, base account doesn't. Okay, we can use. We have been using OpenZeppelin for auth. Instead, today I'm gonna use Solidity by Vectorize. So I haven't used it, but hopefully it's similar. Owner. Okay, there. Am I missing something? There isn't internal function set owner internal sets owner directly without authorization guard. Check owner ownership handover. So there is this a delay or of some kind? Request ownership handover. Okay, so it is a delay of some kind. Transfer ownership, cancel handover. So in between that grace period, if something happens, this will cancel the handover. So I'm still not used to this part where Vectorize just put assembly snippets everywhere. Yeah, I can't even understand bunch of most of the things, not even bunch of things, most of the things. Yeah, I know it's a skill issue, but still, does like saving 2 gas uh, is good for like readability instead of saving 2 gas, like this should be more readable. It is. I just don't know assembly. I know that. Yeah, I know that too. What should I do? Public read, public write, public update. Override to return true to make double initialization. Okay, this sounds good enough, I guess. Where if we override this and return true, we can't call this twice. Okay, we can import it and start trying to implement it, which is ownable, then path, which is auth slash ownable.sol. Okay, is sorry, ownable. Now we can first implement this. which should prevent return true. And now in the constructor we can call this, and hopefully nothing will break. Constructor address owner. Okay, we need our entry point underscore owner. Underscore entry point. Okay, for now ignore that. Let's start with creating this. We also need bunch of events. So set pub key. What else? Set pub key. I guess that's the only event we need. We need errors. Call failed. I don't know. That's the only thing I can think of right now. Struct public key bytes 32x bytes 32y. Signature, is the same thing, just different components, R and S, then R, signature, public key. Okay, this is done. Oh, dude. Are people watching from Twitter? I'm just checking Twitter. Are people watching on Twitter? Or I'm just wasting my bandwidth? Because streaming on two platforms from same device, like it's taking 20 Mbps. So, but B is small, so I don't know, it's megabytes or maybe bytes. Who knows? Okay, back to working on this. Now we can create these. Entry point s underscore entry point, set value of that s underscore entry point equal to underscore entry point. Next, public key private s underscore public key. We also need that. public key memory underscore public key. You can store it with underscore. Okay, so this part is done. We need few functions. First is internal, which is underscore set public key, change public key, execute user op. So this uses the interface described in ERC-4337. I haven't worked with that particular part, but it's pretty simple. Let me just check it. Yeah, it will have this. Basically, what this is, when entry point sees selector for this function, execute user op, entry point creates the call data. Creates the call data which sends packed user operation and user operation hash to this particular function. In the regular user operation flow, it just takes the call data bytes and executes the whole thing on the account contract, and account contract needs to handle that. Also, we need to construct it accordingly. The developer or the web app who is constructing the call data on the front end, on their front end. But in this scenario, we still have to do that, but there will be extra step instead of just being from this. There will be one extra step between entry point calling the entry point calling the account contract and account contract executing the call data. In the regular flow where we are not using execute user of function, just one single step. Here there are two steps. Let's try to use it. It's not actually fun, and I don't even know how it will work, but let's see. Function underscore set public key memory, public key call data, public key internal, and returns nothing. We just need to set it to s underscore public key and we need to create the event for it. Event P256 account underscore public key changed public key changed, and we can use public key, old public key, and pub key, new public key. And we need to emit it. Emit P256 changed s underscore public key comma public key, or we should say like new public key. It's much more clear which public key we are talking about. Okay, this is done. And instead of using sub, okay, memory. Now we have change public key, which will be admin only function. Change public key, pub key, memory, new public key, public only owner, underscore set public key and new. This is done. We already know execute how it will work. Function I want to say like I want to create a user a modifier, but I want to check if there is already one. I don't really think so. It's required from entry point this function. Okay, there isn't one. So we just have to use the function. Public, not even public, like external. Let's start with this. The function arguments will be address, destination, UN256 value, then bytes memory or bytes call data, and we can just execute all of those. Boolean success, destination dot call. We can pass the data and value. Done. Require success. And we can pass the custom error equal to p256 account underscore underscore call field bytes data. Sorry, error data we can say, or error bytes memory error. Yeah, in our case it should be error, because we won't handle if some if there is any value. Even if there is any value, we are not gonna handle it, so we are gonna assume it's an error. So I can say call failed and pass error. Who knows? No, we still haven't implemented this. Return s underscore entry point. Okay, we have to implement this part. Signature aggregation, that's not an issue. Not aggregation, signature verification, that's not an issue. Let's import account execute I account execute interface. No, we need this. Now this is done. We can say user operation hash, and I don't really want to say view right now, or for now we can say view, but it will definitely change soon. I, what can we do? I don't know what I can do. Okay. Um, yeah, for now we'll just do the same thing what we did here, but we are gonna decode decode the user of for these three values. Let's go ABI dot decode user op dot call data comma address UN256 and bytes. sorry, type bytes memory is not implicitly converted to call data. Works. And do the same. Function, okay, view. We need to remove it. Okay, this part is done. We have to rearrange the functions in the style guide. I don't know. I don't remember the style guide. We'll see in the browser. Let's go. Solidity style guide. Where was, yeah, the order, which is constructor. We don't have receive, fallback, external, public, internal, private. We have one. We can change this to external. Let's remove, let's put all of these at the top below constructor. External, public, okay, public is here, then internal, and there are no private ones, so I guess that's good enough. Now back to our signature validation. First we need to decode the signature, then create the signature. No, we don't need to create it. So we don't need this struct. This can go. Decode the signature, call, sorry, decode the signature, call, no, verify the signature, and return correct validation data. For validation data, I want to put a value there for how long. So for how long this signature is valid, which is 1 hour from now. I want to check. I don't know, are they using timestamp or something else? So that's the part I'm going back to. ERC-4337 EIPs.ethereum.org. Okay. EIPs. pack validation data. Okay. Timestamp value. Okay, valid after, we can say 0, and valid until like 10 minutes from now. So yeah, when this user operation is getting bundled. I want to check something. Okay, back to VS Code. Decoding the signature, we have bytes 32R, bytes 32S, then abi.decode, user op signature, comma, bytes 32, bytes 32, verify the signature. For this, we need to import the user operation lib so we can generate the digest. Helpers user operation lib. Okay, no, wrong. It's core, not helpers. No. Okay, understood. Yeah, now. Another step is get user. We already have the user operation hash. Yeah, so library is not needed. Is verified p256 dot verify signature. This should take user operation hash s underscore public key dot x, s underscore public key dot y, then rs. And we need to if is verified, then we'll return some value. I want to check helpers parse pack. this function. Let's import that. Helpers. Is verified. Then first value for this back to the helpers. First value is valid until valid after. So event 48 log dot timestamp plus 20 minutes and event 48 blog dot timestamp. No, that's not, that shouldn't be correct. Else, oh, we don't need if else. We can just use this because this will be true false anyway. Okay, that's good. I guess we have our contract. Everything, every function is there. Whatever we wanted, all the errors, events, constructor is there. Cool. Yeah, I guess that was it for today's stream. Maybe tomorrow I'll start writing the unit tests and see how we can test this. Also, I want to work on something interesting. This is not interesting now. Account abstraction is getting boring for me. Let's see if we can find any interesting library in the vectorize. Interesting contract in the library. Date time, deploy less, pre-deploy. Okay, that's not interesting. Okay, so this is for generating the random number, pseudo random number. So I guess that's why, yeah, pseudo random number, PRNG. What else is there? Zip, libzip. What does this do? Okay, it compresses and decompresses bytes. We should try this on our call data, passing it in the call data, and then so here instead of taking 3 arguments, we're going to take 1 and then decompress that and see how things work. It may be interesting, it might not be, who knows. We can see. This might be useful when you have a very big chunk of byte bytes you are passing to function call. But in our simple contract, like this small of a contract, I don't think this is interesting. This is very useful. We have web auth. I want to do this after BLS, ECDSA, P256. Only this part is remaining, but I have to read about how this works. But it's P256 only. Some things are different. Some minor changes. Okay, red black tree. That's also not interesting. Or at least I don't know if it is interesting or not. By the name, I don't think so. Gas burner. Yeah, this was funny one. You can burn that much amount of gas. So if you pass like 10,000, this function will burn 10,000 gas. Yeah, this was interesting library. I don't know why someone will go and do that voluntarily. Okay, in token, I haven't used this. What is this? Royalty. NFT royalty. Tokenized vaults. Yeah, this is DeFi related. I'll read about this and we can work on a project that uses this. 4626. And this is for 6909. No, it just says simple implementation of EIP 6909. Okay, ignore that. I know what we are doing next, which is tokenized vault, and using this in maybe lending application. I have built a lending application, so let's see if we can in a way push this and see. Cool. Okay, that's about it for today's stream. If anyone is watching on Twitter, yeah, hopefully you liked it. If not, let me know. And see you guys tomorrow, same time. You already know what we are gonna do, but yeah, see you same time tomorrow. Cool. Have a nice day. And also, if you like the stream, please do subscribe to my YouTube. And if you are on Twitter, give me a follow. I'll probably follow you back if you are interesting enough.